In today's session, we will see how to find median for raw data, discrete frequency distribution, and grouped data. First, if we see at the definition of median, median is the value of the variable which divides the data into two equal parts. One part will have values which are greater than the median, and other part will have the values which are less than the median. So, median is the exact midpoint of the data. To find the median, first we have to arrange the data in either ascending or descending order. After that, we have to find the midpoint. So how to find the midpoint is, in case if we have odd number of values in our data, then we will get an exact midpoint. But if we have even number of values in our data, then the midpoint would be a average of middle two values. Say for suppose if I have 5 values in my data, then after arranging the values in ascending order, third value would be the median. In case if I have 6 values, then I should take the average of third and fourth value. Median would be equal to average of third and fourth value. So let us see this with the help of few examples. Now let us consider this raw data. Here the data is not arranged in any order initially. So the first step would be to arrange the data in an order. Say if I arrange them in ascending order, it would look something like this. And now if we see at this data, we have got 9 discrete values. So the value of n would be 9, means number of observations in the data. After this, we have to find the value of n plus 1 divided by 2. In this particular place, it is 9 plus 1 divided by 2, which is equal to 5. So, the fifth value from the arranged data would be the median. In this case, it is the 25. The fifth value is 25. So, 25 would be the median for this particular data. Say if I have another value here, to check the case when we have even number of values in our data, we will take another value at the end of this data, say 63. Now what happened? We have got even number of values in the data, means we have 10 different values in the data. N is equal to 10. Now n plus 1 divided by 2 would be 5.5. So 5.5 position in this arranged values means we have to take the average of fifth and sixth values. So in case of odd number of values, we can directly pick from the data, but if we have even number of values, we have to consider taking average. So in our case here, it is the average of 25 and 27, which is equal to, means we will use 25 plus 27 divided by 2. That's how we find the average, and here it would be 26. In this way, we can find the median for raw data. Now let us look for the frequency distribution. When we have discrete frequency distribution, means we will have discrete values, and how frequently each value has appeared in our data will be represented in a tabular form. Now considering this tabular form, first we have to arrange it in order, and I prefer arranging it in ascending order, so we did that. After arranging the data in a order, at times we will get in any order, but first we have to see that it's arranged properly. After doing that, we have to do the cumulative frequency for each and every class, which is nothing but sum of frequency of that particular class with the frequencies of preceding classes. We have to take all the preceding classes and give that sum, which would be the cumulative frequency of that particular class. So let us see how to find the cumulative frequency. For the first class, we can directly write it down to be 6 because we don't have any preceding class. But for the second class, here the frequency is 7 for that particular class, and we have to add this to the frequency of previous classes. So 7 plus 6 equal to 13. And for the third class, we need to find cumulative frequency by adding all these three frequencies, or we can add the frequency of this class with the cumulative frequency of the previous class. So 9 plus 13 equal to 22. Like this, 12 plus 22 is 34, 18 plus 34 is 52, and 8 plus 52 is 60. When we do the cumulative frequencies, the cumulative frequency of the last class would be equal to the total number of observations we have got in a particular data. So here the frequency is nothing but the number of observations for each and every class. So if we add all these frequencies together, then it would be equal to 60. After getting this value, the process is similar to what we have seen for the raw data. That is, we have to find total number of values plus 1 divided by 2 to locate the median in the data. So in this case, the n equal to 60. So 60 plus 1 divided by 2 will give the position of median in our data. So it is 30.5. When we got 30.5 to be the position of that median, from the cumulative frequency column, we have to find a value which is greater than or equal to the value we have obtained here. So it's 30.5, so the value is 34, and this would become our median class. So 34, and the corresponding value we have here is 62. So this particular value would be the median for this data. This is how we will find the median when we have discrete frequency distribution. Now let us see how to find median if we have grouped data. Grouped data, we all know that it could be either exclusive grouped data or inclusive grouped data. So first we have to check which type of data we have got. If we have got exclusive class intervals, means a higher limit of a class would be equal to the lower limit of next class. Then we can proceed to the next slide. But in case if we have inclusive class interval where the higher frequency of a higher limit of a class is not equal to the lower limit of the next class, we have to find the average of those two values and write the average to be the limits of both. Means say in this first case 19 is the upper limit of the first class and 20 is the lower limit of the second class. Here we have to take the average of these two values. The average of 19 and 20 is 19 plus 20 divided by 2, which is equal to 19.5, and these two values which we have taken to calculate the average should be replaced by that new value, that is the average value 19.5. Here it would be 19.5 and here also it would be 19.5. Let us write it down. So this is how it looks. See, we took the average of these two values and we replaced those two values with the average. Even in this case we have to take the average of these two values and we will replace those two values with the average. So like this we will keep on doing. So why we do this is this would make the class look like exclusive class. See here the upper limit of a class would be equal to the lower limit of the next class. So we have to first convert the class to be a exclusive class interval and then we have to start finding the median. So let us take any one of these two things and find the median in this type of data. So I have taken the inclusive class interval. So we know that if we get an inclusive class interval, first we have to convert it into exclusive class interval. If we do that, this is how the class intervals will get converted. Now it's same. Once we change the class intervals, we have to find the cumulative frequency the way we have done in the discrete frequency distribution. It's the same. The cumulative frequency is nothing but the sum of frequency of that particular class with the frequency of all preceding classes. So here the first one 3 would remain as is when we write down the cumulative frequencies, and for the next class 3 plus 3, that is 6, and for third class the sum of all the three values is 10, and so on. If we proceed, we will get the cumulative frequency for each and every class. And here the last cumulative frequency indicates the total number of observations in the data, which is 100 in this case. So now we have to do n plus 1 divided by 2, and here 101 divided by 2 is 50.5. Now we need to look at the cumulative frequency which is greater than or equal to this particular value, that is 50.5, and value greater than 50.5 is 63 here, which would be the median class. So this one would be the median class. Now once finding of the median class is done, in this group of data we can't directly go back and see what's the value because it's a range of value. Here it's not one particular value, so we need to follow a particular formula to identify the median. First, let us look at the formula. The formula looks something like this: median equal to L plus n by 2 minus m divided by f into c. The values of L is nothing but lower limit of the median class that we found now. N is the total number of observations. M is the cumulative frequency of the preceding class, which is a class preceding to the median class. F is the frequency of the median class, and C is the class interval. Means we just have to separate the upper limit from the lower limit, and that would give the class interval. Now after seeing at this formula, let us get the values from the table we have previously and just substitute the values. But first let us identify these particular variables from the data. So first if we look at this is L. L is nothing but the lower limit of the median class. Here this is the median class and the lower limit would be this one, 49.5. Let us keep that in the formula. So L plus n is nothing but the total number of observations. In this case it is 100. 100 divided by 2 minus m. M is nothing but the cumulative frequency of the class preceding the median class. So immediate preceding class is this one. So this would become m. 31 is m. Let us write it down here, and the next one is f. F is nothing but the frequency of the median class. So the frequency here is 32. We'll write it down. And then C is nothing but the class interval. So if we take the class interval here, we need to separate the upper limit from the lower limit, and the difference here is 10. And after simplifying this, we will get this particular value. So I have first simplified this part and then just added it to 49.5, which is 55.13 is the median in this particular data. So now we have looked at how to calculate the median. The next one would be a sum which you can use to practice what we have learned so far. So this is a group of data. You can pause the video here and try to use the formula we have seen to calculate median for this data. Now let us see how to solve this. I hope you all try to solve it, and if you're done you can check the answer. If not, let us go through the process once again. So first point is to find the cumulative frequencies once the data is in order. So cumulative frequency is nothing but we have to add the frequency of that particular class with the frequencies of previous classes. For the first one I don't have anything, so the cumulative frequency is 1. Starting from the second, we just have to add like this: second class with the previous class, so 21. For the third class, it is sum of these three values. Fourth class, sum of these four values is this value. Like that, we have to keep on adding. And the last value would give the total number of observations in this particular data. So now we have to find n by 2. N by 2 is nothing but 162.5, and we have to find a value in the cumulative frequency column which is greater than this particular n by 2 value. So the value greater than 162.5 is 180, and this would become the median class. Now after finding the median class, let us get the formula, and we will try to find each and every variable from this formula and substitute it over here. So L, the first thing, is nothing but the lower limit of the median class. This case it is 250, and n is total number of observations, that is 325, minus m. M is the cumulative frequency of the class preceding the median class. This one, 118, let us keep it there. And F is the frequency of the median class. C is nothing but the class interval, means we have to subtract the upper limit from the lower limit, and in this case it's 50. Now after simplifying this, we will get the value. So this one would be the median for this particular group. In this way, we can identify the median values for raw, discrete frequency distribution and group distribution as well. Thanks for watching the video.